Hello friends, today I Moinak Shah is going to present a brief description of interstitial free IF bake hardening BH, dual phase DP, trip and tape steels. So first of all, I shall start discussing about the interstitial free steels. The composition of the interstitial free steels, as we all know, that they are the low manganese steels. That is, in other words, they contain manganese less than 0.35%, and all these percent are in terms of weight percent. So the amount of carbon in IF steels is less than 0.008%. The amount of nitrogen less than 0.005%, silicon less than 0.3%, aluminium less than 0.07%, titanium almost equal to 0.1%. Besides, there is also niobium, which is less than 0.04%. As the name suggests, that interstitial free steels do not have any interstitial atom to strain the solid iron atoms. Generally, about 40 parts per million of nitrogen is used for the interstitial free steels. Now, before studying more about the interstitial free steels, now let's discuss about the role of various microalloying elements in the interstitial free steels. The first microalloying element that we will be discussing is silicon, which is required to prevent the carbide formation as it suppresses the activity of carbon. The titanium used along with 40 ppm nitrogen, thereby forming titanium nitride, in small amounts leads to grain growth control, and in larger amounts it leads to precipitation hardening. Aluminium is one of those microalloying elements which is responsible for increasing the martensitic start temperature in the TTT, that is time temperature transformation, or we might also say the IT isothermal transformation curve, or the CCT curves, that is the continuous cooling transformation curves, because it increases the rate of nucleation and growth of ferrite and pearlite. Besides, niobium is used for precipitation hardening and increase in recrystallization temperature. Now, if steels have relatively coarse ferrite grains, and so following the Hall-Page behavior, we cannot expect high yield strength from the if steels, as sigma ys, that is yield strength, is found to be inversely proportional to small t raised to the power half, where small d is the grain diameter. Then high Langford coefficient is possessed by the if steels, and high Langford coefficient refers to high R value or high plastic strain ratio. So the if steels have high formability and are the extra drawing quality steels, or the EDQ steels. Basically, depending upon the formability of different grades of steels, there are three different types of drawing qualities of steels. The first type of steel is termed as the drawing quality steel. The second is the DDQ, that is the deep drawing quality steel, and at the same time the steel which has the highest formability is also known as the extra drawing quality steels. We should not say the highest formability, rather these steels have very high formability, that is the EDQ steels generally do possess the high formability. At the same time, for the if steels, there is high crystallization anisotropy owing to high R value, so they have strong recrystallization texture. So now what is texture? It is the arrangement of unit cells in space. In order to remove interstitials from the solution, the carbon and nitrogen are added to the if steels, as titanium has high tendency